Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's apply the differentiation rule or the chain rule in computing the derivative of this given composite function. Our function here, a binomial expression raised to a negative exponent, and this is actually an example of a composite function. Say our h of x is x to the power of negative 3, and our g of x is the binomial expression 2x squared minus 5. Our f of x here is actually h of g of x, where we substitute the entire function g of x on our x value or x variable on our h. That is why we have here, you will have 2x squared minus 5, but that's to the power of negative 3, as instead of x, we'll have this final form. Okay, so this is clearly an example of a composite function. Now, some of you might also say to bring that down, making the exponent positive, but since our goal here is to differentiate that, let's automatically proceed to the rule in differentiating composite function, or also known as the chain rule. The chain rule is actually following this idea. If we have here f of x again, which is h of g of x, the first derivative of that uses this formula h, what the derivative of this, considering this as one entity, using the power. Okay, you will have here the rule for differentiating a power, then times the result for the derivative of the expression here, g prime of x. Okay, that is the chain rule. Okay, now let's move into the possible solutions now. Before solving this as itself, let us also show the possible values or expressions for this, so that we could just automatically substitute it later. So with this now, we're going to treat this as one, okay, as a whole expression. Then you're going to have here your rule for power. So you'll have here negative 3 times 2x squared minus 5, that's raised to the power of negative 3 minus 1, according to the rule in differentiating a power, that's n minus 1. Hence, you will have here negative 3 times the binomial expression 2x squared minus 5 raised to the power of negative 4. As for g prime of x, and this is our g of x given here, so you're going to use here the rule on difference or sum, and your 2x squared is a constant multiple, so that's 2 times 2x to the power of 2 minus 1, okay, minus 0, as this is the derivative of the constant. Hence, your g prime of x is just simply 4x to the power of 1, or just simply 4x. With this now already identified, we can now go to the formula as mentioned here. This is the derivative of the entire expression, treating this as 1, then times your g prime of x, which is the derivative of this grouping symbol. So you will have here negative 3 here times 2x squared minus 5 raised to the power of negative 4, then times 4x, which is the result for this. You can multiply this too, so you have negative 12x times 2x squared minus 5 raised to the power of negative 4. Since our given is already a negative exponent, I might accept this, but of course, we would like our exponent to be positive, so you are going to move the entire expression, not this one, because this is negative coefficient, only the negative exponent according to the law of negative exponent. Hence, our final derivative here is the numerator 12x, negative 12x over 2x squared minus 5, and the exponent now is a positive 4. Okay, so this is the result for this given function, identified as a composite function, using again the formula for our chain rule. Thank you very much for watching. So what are you waiting for? Subscribe now.